Good afternoon, everyone. I should say good morning. Welcome to another session on engineering graphics with me, Yash Chawla, lecturer mechanical engineering, department at Parul Institute of Engineering and Technology. So we meet after approximately 2 years, and I'm here at BISEC again, but you can see in a completely different environment. We have brought the classroom out to nature, and I have 6 students with me. Let me introduce them. This is Shelly, Kajal, Tripti, Aman, Vipin, and Rahul. And today, for the next 3 hours, that is total 3 sessions, out in the nature we'll be discussing engineering curves. Curves are one of the major part that comes into engineering drawing. It is used anywhere that you see while construction, in the machineries, or anywhere you see, there are a lot of places where engineering curves are used. So today basically what we are going to discuss, I'll just show you in my engineering curves. The 2 points that we'll discuss in the first session, that is classification of engineering curves, and then we will begin with conics. I'll tell you what is conics, and then we will move on to construction of ellipse with different available methods in the first session. Thereafter, in the second and third session, at the end of first session, I'll tell you what is going to come in the second session, and similarly at the end of second session, I'll tell you what is going to come in the third session. So first of all, let us understand the different types of curves that are available with us. We have conics, we have cycloidal curves, then we have involute, we have spiral, we have helix, we have sine and cosine curves. So now what we are going to do is, each and every single curve we are going to try and understand that how these curves are there. So the first is conics. Now conics, what is conics? Conics is a curve which when there is a cone, right, when we take a cone and we cut it into different by different planes, by different angles or by different type, then what happens basically is we get a curve which is known as conics. So any curve which is derived from a cone will be known as conics. So in that, the basic curves that we have is triangle, circle, ellipse, parabola and hyperbola. Okay, moving on, so we have cycloidal curves. Now pay attention on the screen. There are 3 curves that are mentioned here. The first one that you can see is number 1, that is cycloid. The number 2 that is seen, that is epicycloid, and the third one is hypocycloid. Now what basically cycloid is? Cycloid is a curve which is derived by a circle, a point on a circle which moves on different paths. Now see, basic cycloid, what is cycloid? It is a locus of one point on the circle when that circle is moving on a straight line. As you can see, there is a point P on the circle which is shown in dotted line, and there is a blue line, horizontal line. Now that circle begins to move, and that the line that is traced by that point P will be known as a cycloid. Now coming to point 2, now the only thing that is changing is that instead of a straight line, what is happening is that we are having a circle, a small circle with a point P is moving on a bigger circle, and then basically creating the what is known as an epicycloid. And the third one is the hypocycloid. The hypocycloid is a curve. In epicycloid, the circle is moving outside the circle, that is a bigger circle, and in hypocycloid, that same small circle is moving inside the curve and the path is being traced. Okay. Now moving next again, now we come to the involute. Involute, what is an involute? Can anyone tell me? Anyone? Vipin? While unwound, if we have a string which is wound on a piece of cross section, say for example a circle, so when we are unwounding that string, then the curve that we get, every point, for example if this is the way I am going, then my point, that is this finger, will be moving away and away and away from the cross section. So the curve that this point is tracing will be known as an involute, and the involute will depend on the cross section as well. So in this you can see that there can be a circular cross section as shown in point 1, and there can be an polygon. Here pentagon is shown in number 2, so it can be a pentagon, or it can be an hexagon, or it can be an octagon. So it totally depends on what kind of cross section it is. So depending on that, the method will basically remain the same, a little bit difference will be there. Now coming to spiral curves, we all know what is a spiral. We have seen that chakri, the firecracker. So it is something similar. We have different types of spiral curves. We have Archimedean spiral, then we have logarithmic spiral, we have spiral for clock, semicircle, quad, etc., etc. Okay. Now helix, what is a helix? Have you seen a spring? Now a basic spring can be is a very good example of an helix curve. Now helix can be of two types. One can be cylindrical, which will have uniform cross section from top to bottom, and another can be conic, which can have either increasing cross section or decreasing cross section depending on our requirement. Okay. Now sine and cosine curves. Have you, we have since lower standards we have learned how to plot sine curves, how to plot a wave. We have learned that. So sine and cosine curves, these have major applications in the field of electromagnetic studies and radiation and all those points which cover, and mathematics of course. Yeah. Now let's come down to conics. One by one, all the 6 that we have discussed. Now we will see how those curves are basically made. So first of all, coming on to the triangle, now look at the screen very carefully. What has happened is, now I have a cone with me, and that cone, I have a cone and I have a plane. What I have basically done is, I have taken a cone and exactly at the center I have inserted a plane, and that plane has cut the cone into 2 halves. Now this is the cone, I have cut it into 2 halves exactly at the center. Now if I see the cone from the side from which is cut, I will exactly see a triangle. So triangle is formed by cutting the cone with a plane passing through the center. Okay. So this is the triangle. One second. Okay. Now for we have this eccentricity ratio, that is for any curve we have this eccentricity ratio that comes in. Now eccentricity ratio is distance of a point from the focus. Now as if you can see on the screen, there is a focus f that is given. You have seen as you can see on the screen, can you see on the screen? So f is given and the distance of point m is mf, okay, and the distance of the point from the directrix, that is m dash. So the eccentricity would be mf upon m dash. Okay. Now coming onto a circle. Now what I am doing is, again I have the same thing. I have a cone and I have a plane. Now why eccentricity ratio was required to be explained before starting with the curves? That triangle is we can say that it is a curve with, or it can be a polygon as well. But now we come to the basic curves, very basic curves which are directly coming into conics. Now for any curve, eccentricity ratio is different. So as we understand how those curves are made, we will also understand what is the base eccentricity that is assigned to them. So now how is a circle formed? What were we doing is, we were passing a plane exactly parallel to the axis of the cone from the center vertically. Now what I will do is, I will take a cone and I will take a plane and I will cut that cone exactly horizontal to the base of the cone. So and if I view it from the top, what I will have is a circle. Okay. So here it is shown that O, B and B dash is a cone, and I have used a plane A dash to cut the cone horizontal. Then I have the circle, the orange part that you can see is A2 and A2 and A2 dash, which will be the circle that is given. That is the diameter of the circle which is shown. Okay. Let's move to an ellipse. Here the eccentricity of circle is a 0. Okay, it will be 0. Now ellipse. Now the plane which was horizontal, if we tilt it at any angle with related to the horizontal base, then the curve that we will get is a ellipse. Okay, and for ellipse, eccentricity is always less than 1. That means that the distance from the focus is always less than the distance from the directrix. Right, the distance from the directrix of any point on ellipse is more than the distance from the focus. Okay. Now coming on to parabola. Now for parabola, the tilt angle, say for we just inclined it from horizontal, we gave it a little bit inclination and we cut the cone, so we got an ellipse. Now if we cut the cone at an angle which is equal to the slant edge of the cone, this is the cone. If I take a plane which is parallel to this slant edge and then I cut the cone, then the curve that I get will be a parabola. And for parabola, eccentricity is equal to 1. Okay. Next is an hyperbola. And hyperbola, now we were starting to tilt it. What we did is we tilted it a little bit. Then we were having different ellipse. Now when we were tilting it more, we made it parallel to the edge. Then we had an parabola. Now if we go on tilting it and it is almost tending to be parallel to the axis of the cone, then the curve that we get is an hyperbola. Okay, understood? Right. Now we will move on to construction of ellipse. So I'll all of you have set up your sheets properly with the drafters and all the equipments on table. Okay. Now the different methods that are available for the construction of ellipse, we will be discussing 4 methods. The first is the arc of circle method, second is the concentric circle method, third is the oblong method, and finally we will be discussing the directrix and focus method. Okay. So let us move to the first. Here I have given you the dimensions well in hand. Here on the screen we will be just, I will be just portraying that how the points have to be cut and what are the ways, that what is the center to be taken or what is the radius to be taken. The measurements already given to you, which will not be mentioned in the slides. Okay. First we are discussing the arc of circle method. Now let us understand what is an arc of circle method. Now in an arc of circle method, we have an ellipse has a major axis and a minor axis, right? Now here ABCD that is given on the screen is a ellipse. AB is given as a major axis and CD is given as a minor axis, and with it has 2 focal points F1 and F2 as depicted on the screen. Okay. Now for arc of a circle method, these conditions have to stand true. What conditions are these? F1 P1 plus, that is F1 to P1, any point on the circle, right, plus F1 P1 F2, like the distance of any point from one focus plus the distance of that point from another focus should be equal to F1 P2 plus P2 F2. So I am taking 2 points on the circle. Okay. Now what I will do is I will measure the distance F1 to first point P1, F2 to first point P1, and then add both. Then on the other hand I will take another point on the circle, that can be ellipse. Then again I will measure F1 to P2 and F2 to P2, and then I will add both. So both the sums should be constant AB. Okay. The second condition is that F1 to C, that focus to the point, the edge of the minor axis, plus C to F, that is again same thing, like we have taken a point on the circle, but that point is what point? The end point of the minor axis. Okay. It will be equal to F1D and D to F2, means the distance of the 2 endpoints of the minor axis, the sum of those distances will also be equal. No, not the major axis, will be equal. The major axis, those sum will be equal to the major axis, like from one focus to that point, the end point of the minor axis, from that point up to the focus, the second focus, that will be the distance of the major axis. And then last, F1C is equal to C2F is equal to F1D is equal to DF2 will be exactly half of the major axis. Okay. When these conditions stand true, that is the time when we can say okay, arc of circle method is we are implementing. Okay. Now for arc of the circle method, we can find the focus if the length of major and minor axis is given, and if the length of major axis and focus are given, we can find the minor axis and vice versa. So any of these data have to be given, one data can be missing, so we can calculate the missing data. Okay. So moving on, first of all draw a major axis on the exactly as a measurement that is given to you. we will be drawing 4 curves on the sheet. So I hope you have already divided the sheet into 4 parts. Draw a straight vertical line. The vertical line can be cut on the sheet or drawn on the sheet with the use of a drafter. You can mark the point exactly. You can use a drafter. When we keep it like this is the vertical line, so exactly the line that you get on the sheet will be a horizontal line, and you can measure it directly from here. Okay. Now once you have drawn it, you name it as AB. Once you have done that, then the next point will be draw a minor axis that will be perpendicular to the major axis, passing through the center of the major axis, as I have shown you on the screen, and that can be depicted as CD. We can focus here. Okay, and the center can be marked as O. Okay. Now with radius equal to half of AB, that is the major axis, and center as C. Now if you remember in the previous slide we had discussed that the distance of focus from any end point of the minor axis will be equal to half of the major axis. So what we are doing is we are trying to find, we have been given the length of the major axis and length of the minor axis. So what we have to do is next is we have to find out the focus. So for finding out the focus, we will take the radius equal to half of the major axis, and with C as center we will cut 2 points on AB. One will be F1 and F2. Okay.